Hey everyone, I'm Jeff. I'm a staff product manager at Pinecone, and I'm excited to share with you kind of the newest features that we're releasing in August for Pinecone and making vector search easier and better to use. So a quick overview of the agenda for today's webinar is that we'll go through a quick overview of what is Pinecone and remind everyone what Pinecone can be used for. And then we'll do a deep dive in terms of the new features that we're announcing, which are going to be P2 pods, collection, vertical scaling, as well as other new feature adds. And then after that, we'll actually show a brief demo as well, showing you how you can use these new features within our console as well. So why don't we go ahead and dive in? So what is Pinecone? So Pinecone is a vector database is all about making it easy to build high performance vector search applications. So vector search is traditionally really difficult to run in production. I mean, there's so many things you need to do, things like tuning your vector search algorithms, managing your database uptime with high availability, scaling your solution as your data grows. It's a lot of work and typically takes an entire team of engineers to maintain. So you can imagine it wasn't easy for a lot of people to actually go about and actually, implement these vector search applications. So Pinecone is all about democratizing these vector search capabilities for anyone to really empower their application with vector search. So it's extremely developer friendly, it's fully managed and easily scalable. So you don't even need to worry about the infrastructure underneath. All you need to think about, as you can see in the diagram, is, what is my data? What is the embedding model that I want to use to generate these vectors? And then all you need to do is load that data into the Pinecone vector database and then query against it. And then of course, you'll get your results in your application and do, whatever sort of logic you need to on top of that. So a couple characteristics we want to call out about vector search on Pinecone is that, first of all, it's fast. We have ultra low query latency, even when we have billions of items. This really gives users a good experience. You can imagine it's extremely responsive, as well as, we really provide, a good throughput as well, in addition to that too. It's also fresh, meaning that live index updates, when you add, edit, or delete data, your changes are immediately reflected essentially within a matter of seconds, so that, as you insert and your data changes, your search results stay fresh and they stay actually up to date with the changes in your data itself. And last but not least, filtered, which is, I think, a very common ask for many vector search applications and just search in general, is that you want to be able to combine vector search with metadata filters, so you can narrow down your search scope and actually find the most relevant results, as well as potentially increase your your query performance as well. So overall, I think it's to summarize that, say, vector search with Pinecone is super easy just because it is fully managed as well. So you can imagine it's really easy to use. You can get started with a free plan, absolutely no cost to you whatsoever, with a super easy to use API or with a Python client. It's extremely easy to get started. You also, in a managed service, only pay for what you use. You can start free, and then as you upgrade, you can pay only for the hardware that you want to use. You don't need to pay for anything else. It's reliable, and you get to choose essentially a cloud provider between AWS and GCP in the specific region. We will essentially take care of all the uptime, consistency, all the availability, all the other sorts of managed infrastructure, requirements that typically you would have to do yourself. It's also scalable. You can scale from 0 to billions of items with no downtime and minimal latency impact. We also really minimize your own personal overhead. You don't need to do things like monitoring. You don't need to look at infrastructure in Kubernetes. You don't need to do like individual troubleshooting of algorithms like the ANN search algorithms themselves. You can imagine all this overhead is abstracted away from you, and we manage it on our side. And last but not least, it's secure. So Pinecone is SOC 2 Type 2 certified, GDPR ready, and built to keep your data secure. So it's really all about, so all of this is to say, Pinecone is really designed to help you democratize vector search and really empower anyone that wants to start building vector search applications to do it as quickly and easily as possible. All right, and I think with that, I'm just going to hop into the newest features that we released. So we had a big release on August 16th. With 3 major features, as I mentioned before: vertical scaling, collections, which is going in public preview, P2 pods, which is also going in public preview, as well as additional, P1, S1 pod performance improvements. We're also releasing the starter plan to enable people to use S1 pods right away, as well as a price change announcement. So diving right in, So the first feature that we're going to talk about is vertical scaling. And so I think the first point to think about is that accurate capacity estimation is really difficult for a lot of database products. It's notorious. There's a lot of changing factors that impact how much capacity you'll need, how much growth in terms of new vectors or documents that you'll need. So you can imagine all these kind of dynamic factors make accurate capacity estimation really, really hard. The kind of the double whammy of that, of course, though, is that if you don't, accurately estimate capacity, you then need to resize your index as your data grows. But resizing an index is also kind of difficult. It typically requires you, today, it would require you to provision a new index. You need to then re-upload your vectors and then do a live switch in production, which is a lot of engineering overhead itself. So we really saw these pain points and developed a vertical scaling to address them. And so with vertical scaling, you can increase the capacity of a live index with zero downtime. And so the idea with this is that, you don't need to actually, re-provision or re-upload your data. We'll actually online resize your pod sizes so that you can actually increase your vector capacity over time. So we are releasing 4 additional sizes today for all pod types: X1, X2, X4, and X8. And as the name suggests, every size, every step itself doubles the storage and compute capacity of the previous step. And so all of this taken together means that there's really no more precision guesswork on how much capacity you'll need. So you can just simply start with your X1 pods, and then you can, vertically scale as you add additional vectors. And so you don't need to worry about, being super accurate. We can essentially resize online over time as well. So hopefully this makes essentially and saves you a lot of time in terms of your own vertical scaling solutions. So the next feature that I'd like to go into is collections. So when uploading to vectors to a Pinecone index today, those vectors are typically or automatically associated with a specific index serving configuration. For example, I want a P1 pod with a Euclidean, distance metric, and those kinds of index serving configurations are immutable. That means, if you wanted to, let's say, experiment with the different index parameters with the same data, for example, hey, instead of, Euclidean, I want to use, cosine or dot product, you will need to upload, you need to maintain a copy of all that vector data outside of Pinecone so that you could re-upload it. Alternatively, you could then, or you could, re-index or regenerate all of the embeddings for your vector index. But as you can imagine, that kind of pattern is super hard to maintain and is really prone to error. So what we wanted to do is actually enable customers, enable users to introduce a new capability called Pinecone called collections. So a collection, you can think about it, is really a set of vectors and metadata that represents the single source of truth of an index. So the idea behind it being that with collections, you can now decouple the underlying vector data itself from the index serving configuration. So what that means is that, once you have a collection of your vector data itself, you can then use that vector data to, for example, experiment with different index settings. You can use that vector data to create new indexes with different similarity metrics and different pod types even, right? To test against, what is my latency on an S1 pod versus a P1 pod. You can also use it for cost saving exercises like temporarily shutting down an index. You can take a snapshot essentially with a collection. You can delete your index as you don't need it, but only when you need it, you can then recreate that index from the snapshot collection itself. So that it really allows you to save money and only spin up, compute when you need it. And of course, for high availability sakes, if you're interested, you can also use it to make up backups of your index. So you can take snapshots in time. And then, for example, if you discover in the last couple of days, let's say the vectors ingested were incorrect and there's no way for you to recover, you can then recreate an index based on this backup as well. So it's really all about giving you flexibility to really use your vector data in different ways. So collections are created today by taking a snapshot of an existing index. As a heads up, we're also developing the capabilities to bulk import and export from, like cloud storage like S3 and GCS, as well as streaming rights to collections are coming soon. So it's really, but I think ultimately we're really excited to kind of introduce this concept to all of you. It really gives you a lot more flexibility in how to use your vector data and really kind of in different ways and experiment and play with it in Pinecone. And the last major feature that we're going to be releasing is going to be our P2 pods. And so what we discovered, as we released our initial S1 and P1 pods, that there was a certain set of scenarios out there that were extremely high throughput, talking about thousands of queries per second, as well as requiring ultra low latency, things like in less than 10 milliseconds or so. And so those scenarios typically are like product recommendations, something on social media apps. These types of verticals themselves have, very large, throughput requirements, just given how many, calls are being made to them at any given time. And so we found that, the P1 pod itself from the performance family wasn't really sufficient. So we actually developed the P2 pods. And the P2 pods themselves are designed to provide up to 10x lower latency and higher throughput compared to P1 pods. And of course, this number itself is workload dependent. So things, for example, like vector dimensionality, as well as distribution, can change essentially the performance characteristics that you see. So you want to be able to experiment with it first to see if a P2 pod is a fit. But ultimately, though, P2 pods are designed to have significantly higher throughput compared to P1 by using an in-memory graph-based index. And so there are a couple of trade-offs. It's not we do trade off some ingestion speed as well as a small bit of accuracy compared to P1 for higher throughput. So we're really excited to have you all on board and start exploring, the P2 pods and seeing if it's a good match. If you already use a lot of P1 pods with a high number of replicas to meet throughput requirements, you may want to consider that P2 pods are actually a good option for you as well. So we're really excited to kind of introduce these new capabilities and have you alongside us as we kind of experiment and develop and continue to improve this new kind of graph-based offering as well. Okay, so I think right now I'm going to do a quick demo. So here we're in the Pinecone console. As you can see, we're in my example project underneath the indexes tab, and I have an index or a provision here. And you can see that this is an index with a cosine metric similarity, as well as P1 X1 pod type and a 784 dimension. So let's say, I wanted to go explore and, let's test this performance. I wanted to be able to test this performance out on a S1 type or even a P2 pod type. So all you need to do now is that you need to go to this button here. It says create collection. Once you click it, it's going to create a collection. It's going to start a collection creation. And then you can find those collections within this tab here on the left-hand nav. So this collection itself is going to take some time to copy all the vectors and the metadata associated with it into the blob store. And then once it's ready, you'll see this actual ready sign itself in terms of the collection, as well as showing you how much size it's taking today. So just to make things faster, I've already taken a collection itself and copied it over. And once you have this collection here, what you can do is that you can then use it to create a new index. So once you have this new index here, you can also do things. You can notice here that I can change the things like, from cosine, I want to use, let's say, dot product, and I want to use an S1 pod type, and maybe I even want to increase the number of pods for my index itself. So once you do that, we actually directly create it in the index view itself. You can see that we have a new set of dot product, a new set of metrics, a new set of pod types and different dimensions and pods, etc. But it's still using essentially the snapshot data from the original index itself. So one other thing that you may want to do, though, is that once you have this, let's say you start upserting a lot of data, you want to then think about, hey, how can I then increase the amount of capacity, right? Because let's say I'm meeting my capacity requirements. All you need to do that now is going to be click the configure index. Once you click configure index, you can both change the number of replicas if you need to scale up throughput, as well as pod size if you need to scale up vector capacity from a storage perspective. So doing so, you'll see that the pod type is going to be updated in the background without any touch from your perspective. And I think everything will be taken care of seamlessly in the backend itself. And you can start upserting these additional kind of vectors based on your new pod type immediately. So that's it for the demo, and I'm going to switch back over to the slides. So last but not least, of course, there's a number of additional features and enhancements that we released as part of this August 16th release. We released, notably, a new in-house developed vector storage engine delivering up to 50% lower latency and 50% more throughput on average for P1 and S1 pods. So this vector store is actually a completely in-house developed vector store. It's optimized for random multi-gets, really low fetch variance, like super minimal storage overhead. And we actually, and these kinds of savings, we're going to be passing on directly to you. You don't need to do anything more. We'll automatically roll this out to your existing S1 and P1 pods. And so you guys should be seeing a improvement in performance. Of course, the performance improvement will vary depending on workload, but we're really excited to be able to pass on both these costs as well as these performance improvements to you as well. The second note is that users on the starter plan can now choose between a P1 and S1 pod. And that means if you choose an S1 pod, you can store 5x more vectors compared to the P1 pod. Of course, just as a caveat, people on the starter plan still will be limited to a single pod of quota, meaning that you will need to, if you have an existing P1 pod, you'll need to delete it and then recreate essentially another S1 pod instead, because you're still limited to a single pod. But this should allow you to test out the S1 pods if you want to test out some more cost sensitive and less latency sensitive scenarios on the starter plan. And last but not least, there's new pricing that will go into effect for all new users starting on September 1st. So it will this pricing will go up essentially depending on your plan and cloud vendor. So anyone not yet on a paid plan can lock in your current rates by upgrading and launching at least one pod index by August 31st, 2022. If you have any questions about pricing or any concerns on that front, please reach out to us. We're happy to work with you and alleviate any concerns you guys may have. And that should be about it. So there are a bunch of links here in case you're curious about various types of notebooks and data and examples, as well as the console itself. If you guys are curious, but essentially this is kind of a highlight of all the new things that came from the August 16th release. We're really excited to continue pushing the boundaries of what's possible on a managed vector database service, and we're excited to have all of you on board with us. If you have any questions, don't hesitate to reach out. We're really engaged and really excited to hear any feedback or questions you may have.